My name is Tarin, and I'm very glad to be here. I want to talk to you guys today about AI, of course. The question, of course, is what is AI? What does AI mean to all of us and to everyone in the field here? For me in particular, and I'll talk about my journey as far as how I came to this conclusion, modern AI to me is more akin to signal processing 2.0. And what I mean by that is traditional signal processing has a lot of times been about taking, Fourier transforms and wavelet transforms of different types of signals in the world, doing something with their coefficients, playing around with them, taking out some pattern, right? What we have today, though, is the ability using AI, using signal processing 2.0, as I like to call it, to extract patterns from data and let the data speak for itself. And this was a very ubiquitous type of interpretation. It was a very powerful form of some interpretation that I started to realize, because this is something that I think cuts across many different disciplines. I want to take you on that journey and show you how this very powerful tool can be used to understand ourselves, in particular the nervous system. So let's start with a little journey, my personal journey. I started off as a intern over at Motorola and the U.S. Army Research Labs, and a lot of wireless algorithm design over there was about jamming and anti-jamming. So in the Army, we do jamming, and Motorola, we do the anti-jamming usually. And really, that just involved taking a bunch of wireless signals from the air and trying to unpack them, right? Trying to remove the jammer, maybe some bad guy, and trying to bring out some of the good guys' communication signals, right? And the AI there was, maybe not that sophisticated, but it still did the job. It still did this sort of blind source separation, if you like. And then like any other good Beltway bandit in Washington, D.C., I then moved on to other defense work, this time with Prodigy and Lockheed over at Newark, Naval Underwater Warfare Center. And the algorithms that we worked on there were perception algorithms for submarines. And the type of work that we were doing there involved essentially, again, classification and AI and machine learning to, again, separate sources and separate signals from each other, being able to tell the difference between a dolphin and a ship, or a whale and a dolphin, or a whale and a sub pretending to be a whale. I'm not going to get into that. But this was still a very, very hard problem, of course. And once again, I started to notice this pattern of, hey, I'm kind of using a lot of this machine learning and signal processing 2.0 to be able to distill, let the data talk for itself, essentially. Always, of course, wanted to up the ante. I was CTO of Voyage, where we developed self-driving cars for these retirement communities. And we fielded these self-driving cars to give rights to senior citizens in these retirement communities. And again, the challenge there was, of course, to decouple a lot of the semantics from images, from LiDARs, from radars, and things like that. Similarly, at Apple, we worked on, well, the worst-kept secret, let's say. Picture's worth 1,000 words, I suppose. But again, the story was the same. The common denominator here was being able to unpack information from very complex data, right? And I started to notice that, hey, you know what? This type of AI, this type of machine learning is indeed very powerful in being able to extract and make sense of all this information out there. And in doing so, what we're really able to do is to revolutionize human tooling, right? We have all these tools outside. We're able to bring wireless communication to the masses. We're able to see through water. We're able to, tell whales from subs pretending to be whales, in a sense. And we're able to give self-driving cars agency right now, and be able to make them navigate the world or essentially perceive the world in very ubiquitous ways. So if we up the ante here even more, and this is what actually excites me about today, if we up the ante here even more and say we have this very powerful AI engine, it's very concrete, what if we put this against the most complex and sophisticated entity in the known universe, right? The human brain, okay? And this is just a signaling powerhouse through your nervous system. It's just signaling, it's doing all sorts of stuff. What would we get if we were to fuse or interface, say, biological neurons with artificial neurons. And my thesis here is that if we do that, we're going to go beyond revolutionizing human tooling, like we're doing with self-driving cars or wireless or things like that. We will start to really be able to revolutionize human evolution itself. Right? This is the first marriage between something biological and something artificial. And this is something that very much excites me about control labs. So what do we mean by, artificial neurons meaning biological ones? What does that actually mean? It means being able to capture your intention. It means being able to use sophisticated machine learning and AI algorithms to finesse what you're thinking and be able to control things that are outside the restraints of your 2 arms or 2 hands, right? It means escaping the biological limitations of your own control. So to better appreciate this, we have to understand something about the nervous system itself. Your brain, your nervous system, you've evolved to be this input information processor. You're very good at taking all this information from the world. You have 2 eyes, you have 2 ears, you have skin, you can taste, you can smell. It's very, very easy for you to take in information, right? But it's really hard for you to actuate on that. You have a bottleneck there, right? For your brain to actually manipulate anything in the outside world, you have to go through muscles, these big lumbering muscles that your brain has to actuate, okay? Whether it's something as simple as picking up a ball or closing a door, opening a door, buzzing in your dinner guests while you're washing the dishes or something like that, right? You have to go through muscles. Your brain is very sophisticated, but you have to go through muscles to actuate anything in the world. So the thesis here is, because you have this very, very complicated communication network here in the spinal cord in the brain, what if you could actually take all these signals, similar to how we take all these signals from wireless and all these signals for self-driving cars and all these signals for submarines and all these signals, with Netflix or what have you, right? If we take all these signals and we start to apply this type of AI, this type of pattern recognition, we should be able to start to control stuff just by thinking about it. So you ask yourself, what if you can control your thermostat at home just by thinking about it? What if you could control, the doors on your car just by thinking about it? What if you could control the lights in your apartment just by thinking about it, right? And these are things that we can imagine, right? I mean, we're very, it just goes without saying that you have 5 fingers, 10 fingers, right? And you can control 10 fingers at a time. But what if I wanted to control, 6 fingers? Like, why be limited to 5? Why be a slave to evolution in this sense, right? What if you wanted to have the same dexterity as an octopus? Why not? What's stopping you? Why be limited in control by your biology is a central question here, right? We want to essentially be able to, this is a controversial slide. We want to be able to, give you a huge amount of augmented control that's never been seen before in biology. We want to do it en masse, and we want to do it non-invasively as well. We're not going to drill holes in your skulls or anything like that. And we want to bring this to the mass market because we believe that this is something that's going to be a huge, huge market opener. And here's how we're going to do that. Okay. So once again, your brain is very, very sophisticated. This thing between your 2 ears, very, very sophisticated organ. What happens is that, luckily for us, the homunculus here shows us that a big part of your neocortex is actually devoted to fine motor control here. And you can see, for example, that a lot of it's devoted to your fingers and thumbs and things like that, right? So your brain has heavily invested in being able to do fine-level control. And typically, when you want to come up with a sequence of actions, you want to do some sort of control, right? Your brain will take all that intentionality and convert that into a sequence of actions. I want to reach over to this bottle of wine. I want to uncork it, and then I want to pour it and put the wine bottle down, pick up the glass, bring it up to my mouth, maybe smile, right? That's a sequence of actions. It's like a dance. And that intentionality is being encoded in your brain. And it's being encoded as a series of electrical impulses that get sent down to your spinal cord. Okay? So the key takeaway from the slide is that your brain has already done a huge amount of heavy lifting for you as far as taking this nebulous intention and converting it to a discrete set of input signals that is being sent to your spinal cord. Okay? Once it's here, what ends up happening is these intentions, these electrical signals, if you will, go down to a particular vertebra, and from there on to motor neurons. And fortunately for us, it gets much, much simpler after that, because all your muscles are really doing is amplifying those signals, right? So your muscles are like this huge amplifier of intention, if you like. The signals, the intentionality already exists here. And so using that, through electromyography and through dry electrode technology, we're able to essentially sense this chorus of intention in your arm, right? And using this AI, the signal processing 2.0, the very concrete form of AI, of machine learning, we're able to take that and decode this chorus into particular intentionalities that you might intend for from different muscles across different points in time. And from there, you're off to the races, right? With all these signals in hand, you're off to the races. This is, of course, akin to, a different way of thinking about it is, imagine taking a neural network or some machine learning algorithms where you're processing natural signals like those images over here, and we've all seen things like that. You can also process other type of natural signals, like with audio. That's another natural signal that can be processed by machine learning, by this type of AI. But the most natural signal that there is those given by your biological neurons. So what we're doing is we're using AI to process the most natural signal out there in your body to try to give you augmented control. We don't want to have AI, replace you or, kill you, right? We want to use AI to augment you, right? We want to use AI to bring forth this next step in our evolution. If you even go one step further, you can actually have what's called adaptation. And everything you do, by the way, is about being adaptable. What does this mean? This means that if you have a feedback loop and you start to bring your own brain into this control loop, this is something very new. And to make it very concrete, you can imagine that I'm in the business of playing music just by thinking about it. And here I am. I want to tune this guitar, say, on the sides. And I'm thinking about the knobs that I want to turn and sort of tune, right? So I'm thinking about it. That's my intention. It's being sent to my arm. It's being decoded and transmitted to this type of digital guitar. And it's being tuned. And now I can actually listen to what this guitar sounds like and control that tuning just by thinking about it. So I've come full circle. I'm able to now have this adaptive feedback loop, in a sense, right? This is something that's unheard of as far as being able to control all this with your own mind. The ultimate goal here, of course, is to say that intention capture, what is that about? It's about decoding real neurons using artificial ones, right? Putting the two together, having them come full circle in a sense. I want to show you here a video of our CEO, Thomas Reardon, actually using our device here, and this is quite old at this point in time. But you can see that in this particular case, he is moving his arm, but he's able to replicate the movement of his hand simply by using this device. And it's sitting here on his arm, right? And so this device is able to capture this signal, decode it, and immediately start to replicate it there. Here, the intention of his motion is being decoded. He's not allowed to move. He's not moving, but his intentionality is being captured over there. And this video, we see that the continuous variable of grasp power, is also being decoded here very seamlessly. Okay, we'll skip that. Goes on and on, right? And so extrapolating from that, you can imagine what would it be like if I was able to text you, to text my partner, to text my friends, just by intention. Maybe I'm, I don't know, doing the dishes. I keep using doing the dishes as an example. That should be automated. But let's say that I was doing the dishes and I wanted to text someone. I should be able to do this very, very seamlessly with technology like this. Another example here is, again, of our CEO typing. In this case, he has 2 devices, and with a phantom keyboard, there's no camera involved here. He's able to start to faithfully type some sort of text here on the screen. And again, there's no camera, and there's no, there's nothing sort of taking in his finger readings or something like that, right? We're just decoding this straight from his nervous system. And so the question I would pose to everyone here is, what would you be able to do with more control? This is the question that I'd like to posit to everyone here. And I'd like to get everyone here to start thinking about this new domain, which we can start to use AI for. So we're shipping units by the end of the year, our initial units. We're a New York-based company, but I'm actually opening an office here in San Francisco itself. And I'd like you to join me on shaping the next era of human evolution. Thank you.